Hi, welcome to another lesson at EDU Solutions Institute. Now, on today's lesson, we are continuing on the CSEC chemistry syllabus, where we were looking last week at acids, base, the neutralization reaction to form salts. Now, in this week's lesson, we are going to explore on the different ways in which we can create salts, which we call preparation of salts. Now, if we explore how do we prepare salts, if we take, for example, this little cartoon, that gives us a little idea of how we can create the basic salt that almost everybody knows, sodium chloride. So here we see that Cl and H are together, holding hands. They are a substance. This is called hydrochloric acid, HCl. And then we have sodium, all big and mighty on the side, saying, hey, I'm going to take that Cl from the H. Now, the reason why sodium has this big structure is if we remember from previous lesson, we did what we call the reactivity series. And we see that sodium is highly reactive. So therefore, it has the power to remove almost any metal from a substance and take the non-metal. And that's what we see that happens here. So we get NaCl. Now, in last week's lesson, we looked at what is a salt, right? So this is just showing you exactly how does sodium zinc sulfate, in this case, became a salt for this reaction between zinc hydroxide and hydrochloric acid. Now, when preparing salts in the lab, there are two factors that we need to consider. One, is the salt going to be soluble in water? Or two, are the materials that we're making the salt with, are they soluble in water? And that leads us into the solubility table. And this table is very important for us to remember, right? And what it tells us is that all sodium salts are soluble, all potassium salts are soluble, all ammonium salts are soluble, and all nitrate salts are soluble. So once a salt has sodium in it, it's going to be soluble in water. Once it has nitrates in it, it's going to be soluble. Now, it says that all chloride salts are soluble except two. If we have lead 2 chloride or we have silver chloride, those will be insoluble, right? And the process goes like that. All carbonates are insoluble except potassium carbonate, sodium carbonate, and ammonium carbonate that are soluble. So this table here is very important for what's going to come next. Now, here we have that, is a salt going to be prepared soluble in water? If yes, if it's a soluble salt, then we will react with reaction with acid would be a metal with acid, a base with acid, or a carbonate with acid. Right? And then if that is a starting materials for making the salt soluble in water. So if we are the starting materials, if the metal, the acid, the base, the acid, the carbonate, or an acid, if they are soluble, then we will do a titration method. Or if they're not soluble, then we will do excess of each to get the salt that we want. Now, if the salt that we want to prepare is not soluble, then we do step 3, which is we do a precipitation method. So let's look into each. preparing insoluble salts. So these are some examples of insoluble salts, right? So all insoluble salts are prepared by the process of precipitation. And precipitation is basically once we mix things together, because what is going to be formed will be insoluble, it's not going to be dissolved, it will settle as a residue at the bottom of your mixture. So that's what we call a precipitate. So aqueous solution of two soluble salts are mixed. So in order for us to create an insoluble salt, we use two soluble salts, right? So therefore, example, if we're preparing lead 2 sulfate, which if we go back to our table, sulfates, lead sulfate is insoluble, so we know it's an insoluble salt, right? Then the insoluble salt appears as a precipitate and can be obtained by filtering. So what we can do is we pour 50 cm cube of lead 2 nitrate, because this is a soluble salt, lead nitrate, into a small beaker and add sodium sulfate, which is also a soluble salt. So now when you mix lead 2 nitrate and sodium sulfate, we will have lead sulfate and sodium nitrate being formed. And again, sodium nitrate is soluble, but the lead 2 sulfate is going to be insoluble. So therefore, it will settle at the bottom of your mixture. And then step 2 is where we are going to filter. We filter through this solution, so it remains the residue of lead 2 sulfate will remain in your filter funnel. And then notice that we're adding step 3, we add some distilled water. And the purpose of this is to remove any impurities, remove any sodium sulfate that's remaining, any lead nitrate that would have not been dissolved, anything that is not the lead 2 sulfate, we're trying to get it removed so we only have lead 2 sulfate. And then after that, we dry it on a filter paper or on any container that we have. So we have pure lead 2 sulfate as an insoluble salt. Now, how do we prepare soluble salts? We prepare soluble salts by we react the acid with excess of substance, right? Now, this is to ensure that all the acid has been used up. So if we're going to react an acid with excess metal or an excess carbonate or an excess base, right? The purpose of the excess part is to ensure that we utilize all the acid that is in that reaction, right? Though the substance must also be insoluble in water to allow the excess substance to be filtered from the salt solution being produced. Because if we're adding excess of something, some of it will be remaining, right? We want that substance that is going to be in excess to be insoluble, so therefore we can always filter it off from the salt that we're producing. So if we're producing zinc sulfate, and if you go back to the table, sulfate, zinc sulfate is a soluble salt because the only insoluble sulfates are barium, calcium, and lead. So we're producing zinc sulfate as a soluble salt. Right? So in this case, we're using excess zinc and sulfuric acid because we need the sulfate part of the acid. Right? Remember, the acid always gives us the non-metal part. So if we're producing zinc sulfate, we need the sulfate from an acid, sulfuric acid. And then we get the zinc, we're mixing it with excess zinc metal. And then we get the zinc sulfate and the hydrogen gas. Now, to ensure that this sulfuric acid is completely used up, we use an excess of the zinc. Right? Now, from the zinc sulfate being produced, then what do we do from there? we heat that solution, right? So first we will filter it to remove all the zinc that was not used. And then the remaining filtrate solution, we're going to crystalline, which means we heat it, get it to form crystals, and that will form us our zinc sulfate crystals. Right? And that is our diagram to show all of that. Right? And here is another example, copper sulfate. Right? So we're using an oxide, so copper oxide and sulfuric acid. Again, because we want copper sulfate, we have to use an acid that has sulfate in it, and we will get the copper from a copper solution. So in this case, it's copper oxide. Right? Now, in the preparation of soluble salts, what happens if the solid reactant is soluble in water? How can we tell if the acid has completely been neutralized? We use a process that we call filtration, right? So filtration is a process that we can use to determine is all the acids being used. That's a topic that we will explore later on in future lessons, right? So the big question at the end of this salt preparation is, what have you learned? Have you learned about how to create soluble salts and how to create insoluble salts? So if you have learned on the two ways of preparing these salts, just leave a thumbs up or just a yes in our comment section. All right. So thank you guys for tuning, and I hope you understand on how to prepare salts. And I'll see you in next week's lesson.